Welcome to today's Explainer, where we are embarking on a massive planetary-scale forensic investigation. We're traveling millions of miles away right to the rim of Jezero Crater on Mars. This is where NASA's Perseverance rover has been doing some absolutely incredible detective work on a deeply ancient, violently chaotic crime scene that's essentially been frozen in time.
3.9 billion. That is how many years ago the events we're digging into today took place. It's almost hard to wrap your head around, right? Recently, Perseverance climbed up the western rim of Jezero Crater and started looking closely at a specific rock formation they call the Broom Point member. And what the science team figured out is that this sequence of layered bedrock is likely more than 3.9 billion years old. That makes it some of the absolute oldest terrain any Mars rover has ever examined. It's basically a pristine window into a wildly chaotic chapter in the early history of our solar system.
Which brings us directly to the huge question we need to answer today. What exactly happened on Mars 3.9 billion years ago? To really get this, I want you to picture the Perseverance rover not just as, a robot with cameras, but as a cosmic detective arriving at a deeply ancient crime scene. It's sweeping the area for clues, it's analyzing the damage, and it's trying to piece together a timeline of these catastrophic events that fundamentally changed the Martian landscape forever.
Section 1. The Ancient Crime Scene. Let's look at the evidence. To figure out what happened, we really have to look at this massive, 245-foot-thick stack of ancient bedrock the rover's been investigating. Hidden inside that massive stack is a ton of forensic evidence, including 6 totally distinct rock types. But among the most fascinating clues are these tiny, dark, glassy beads, along with rock fragments that are just completely pocked with gas bubble cavities. And those cavities? They're a dead giveaway that these fragments were once entirely molten. Now sure, volcanoes can produce glassy droplets too, but they rarely, if ever, make them in the sheer massive abundance we're seeing here. The evidence points straight to massive asteroid impacts. In fact, the largest of these glassy beads actually rival the ones flung out by the dinosaur-killing Chicxulub asteroid impact right here on Earth.
Let's get a little closer and look at the specific type of rock that makes up these layers. In geology, these are called breccias. Basically, they're rocks composed entirely of jagged, angular fragments. We are definitely not looking at smooth river stones here. We are looking at violently shattered debris that alternates with layers of fine-grained, pulverized rock dust. It is just a stark, undeniable visual of absolute destruction.
And the crazy thing is, this destruction wasn't just a one-and-done event. The way these distinct rock types repeat over and over throughout this thick sequence tells us that high-energy impacts happened again and again across early Mars. Alex Jones, who is a planetary geology researcher and the lead author of this study, explains that this is essentially a record of variable-sized impacts happening at all different distances. He notes, some large impacts took place very far away, some small impacts nearby. Their debris all ended up landing here, constructing this thick section of rock. So it's basically a massive cosmic dumping ground built up over a really long time.
So how did these specific layers actually settle down and form? Well, the data points to a super violent interaction with water or ice. Several of these layers were actually formed by fast, ground-hugging debris flows. We see these kinds of powerful surges on Earth when superheated molten rock suddenly hits water or ice. It instantly flashes it into steam and triggers this rapid, flowing surge of debris. It paints this incredibly vivid picture of early Mars, not just as a place getting violently battered from above, but as a dynamic, steamy, chaotic environment on the surface.
Section 2. A cosmic 1-2 punch.
Now, the physical makeup of the rocks is really only half the mystery. The way they are physically sitting there presents another massive puzzle. When Perseverance looked at some of these layers, the scientists realized they were tilted at extreme angles, some exceeding 80 degrees. That is almost completely vertical. And the impact that created Jezero Crater just wasn't big enough to cause that kind of extreme tilt all on its own. So scientists deduced a catastrophic 1-2 punch. Step 1. A truly colossal asteroid struck Mars way, way back, creating the 1,200-mile-wide Decodes Basin, which is one of the biggest impact basins on the whole planet. This unimaginably massive strike is what upended and tilted those once flat rock layers. Then we have step 2. Much later, a second asteroid, this one measuring about 28 miles across, slammed right into the region, forming Jezero Crater itself. This second violent impact fractured and further uplifted those already tilted rocks into the dramatic, jagged formations our cosmic detective is looking at today.
Section 3. Earth's Lost Geological History.
At this point, you might be asking yourself, okay, why does the pile of shattered rocks millions of miles away actually matter to us down here? Well, it all comes down to this. On Earth, our planet is dynamic.
It is constantly recycling itself. Our very earliest geological history has been fundamentally broken up, deformed, and honestly almost entirely erased by plate tectonics. Mars, on the other hand, doesn't have plate tectonics. Its crust doesn't recycle. And because of that, Mars' ancient crust and its record of all these massive asteroid impacts remains perfectly intact. Mars essentially serves as a pristine, untouched mirror to our own planet. By studying Mars, we get this incredibly rare, unparalleled glimpse into the violent infancy of our own Earth. It's literally a time period that simply no longer exists in our own geological record.
And to finally lock down the exact timeline of this violent infancy, the Perseverance team didn't just snap some photos and call it a day. They collected the physical evidence. The rover successfully drilled 2 specific rock cores right from this site. They dubbed them Bell Island and Main River. These physical samples are literally sitting on Mars right now. The big hope is that a future mission will launch, pick them up, and return them to Earth. Once they're here in advanced laboratories, scientists can use precise dating techniques to figure out exactly when and how often these catastrophic impacts were actually happening.
Just take a second to think about the incredible reality of that era. During this super violent time in our solar system, the environment was just beyond extreme. As researcher Alex Jones points out, you wouldn't see rain or snow falling from the sky. No, it was an almost constant barrage of molten rock droplets and pulverized dust constantly getting kicked up by massive asteroid impacts. He says that if we can pin down the ages of these rock layers using those samples, it would be like reading a cosmic weather report from 4 billion years ago. Let that sink in. A weather report where the forecast was literally raining molten glass.
Which leaves us with one final, totally tantalizing thought. What exactly will the Bell Island and Main River samples reveal when they finally make their way back to Earth? We've got the ancient crime scene mapped out, we've identified the weapons used, and we understand the cosmic 1-2 punch that completely shattered this landscape. But the final timeline, that definitive record of our solar system's most violent era, is currently locked inside those 2 tiny tubes just resting on the surface of Mars, waiting for their ride home. Thank you so much for joining me on this explainer today. Keep questioning, keep exploring, and I'll see you next time.